Alright, so this is section 1.1, which is about linear equations and rational equations. So we're going to start with a few definitions, and then we'll just kind of move on from there. A linear equation in one variable is any equation that we can write in the form ax plus b equals 0, where a and b are both real numbers. They're not imaginary or anything. And a cannot equal 0, because if a is 0, the x just goes away, and we just get b equals 0, which makes no sense. Okay? So an example of this might be something like 4x plus 12 equals 0. Even if you moved the 12 over and said 4x equals negative 12, it's still an equation that could be rewritten in this form, so it would still be a linear equation in one variable. Now, solving an equation in one variable just means you need to find the values of x that make that equation true. These values are called the solutions or the roots of the equation. And we generally find these by creating a set of equivalent equations by performing the same operation on each side of the equation until we have isolated x. So let's look at our first example. It asks us to solve and check 2x plus 3 equals 17. So I'm going to start by subtracting 3 from both sides. So here I'll have 2x, the plus 3 and the minus 3 cancel. 17 minus 3 is 14. And then what I'll do is I'll divide both sides by 2. And so I get x equals 14 divided by 2 is 7. Now before I box that in, I do want to check my answer. You can check by taking this number and plugging it back in for the x and seeing if you get a true statement. So 2 times 7 plus 3, we want to check, does that equal 17? Well, 2 times 7 is 14 plus 3. What's 14 plus 3? 17. So it does work. And so since it works, we can feel confident and we can box in our answer. And so there is our first problem. All right. Next thing, just some kind of general advice and guidelines for solving linear equations. First thing you want to do is simplify algebraic expressions by removing grouping symbols. Get rid of parentheses and brackets by distributing into them and then combining like terms. Number 2, collect all your variable terms on one side and all the constant terms on the other side. So anything that has a variable in it, move it to one side of the equation. Anything that doesn't have a variable in it, move to the other side. Step 3, isolate the variable and solve. And then, as always, check your proposed solution in the original equation and make sure it works. So, example 2 asks us to solve and check 2 times x minus 3 minus 17 equals 13 minus 3 times x plus 2. The first thing we're going to do is distribute into the parentheses to get rid of the parentheses. So 2 times x is 2x. 2 times negative 3 is negative 6 minus 17 equals 13. Here, we're going to be taking the negative 3 and distributing it into the parentheses. So negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. So we've gotten rid of the grouping symbols. We've gotten rid of the parentheses. Now we want to combine like terms. So 2x, here minus 6 and minus 17. Those combine together to make minus 23. Here, the 13 and the minus 6, so that'll be a positive 7 minus 3x. Okay. So we've combined like terms. Okay. The next step is we want to get all the variables on one side and all the numbers on the other side. So to do that, I'm going to add 3x to both sides. So over here, 2x plus 3x makes 5x, and then we still have the minus 23. Over here, the negative 3x and the positive 3x cancel, and all I have left is the 7. Then I want to move the 23 over since it doesn't have an x. So I'll add 23 on both sides. So here, the negative 23 and positive 23 cancel, and so I just have 5x. Over here, 7 plus 23, that'll give me 30. Step 3, isolate the variable and solve. So So all we got to do here is divide by 5. And so we get x equals 30 divided by 5 is 6. Our last step should be to check this solution in the original equation. So 2 times 6 minus 3 minus 17. We want to see, does that equal 13 minus 3 times 6 plus 2? I'm going to cheat a little bit and use my calculator here. So on the right I have 2 parentheses 6 minus 3, close parentheses, minus 17. So that's negative 11. Let's see, does that equal what's on the right side? We have 13 minus 3 times 6 plus 2. That's also negative 11. Negative 11 does equal negative 11. That does work. So x equals 6 is our answer. And so there is our second example. All right. Here's another one. Asks us to solve the equation 2y plus 1 times y minus 1 equals y plus 5 times 2y minus 5. Now the first thing we want to do is get rid of the parentheses. So we're going to distribute. Okay. So 2y times y gives us 2y squared. 2y times negative 1 gives us negative 2y. So what I've done so far, I'm just going to color code it, is I've taken this 2y, distributed it to the y, and I've distributed it to the negative 1. Next, I'm going to take this positive 1, and I'm going to distribute it to the y, and then I'm going to distribute it to the negative 1. So 1 times y gives me y, and 1 times negative 1 gives me negative 1. Equals. Same kind of thing here. I'm going to take this y and distribute it to the 2y, and also to the negative 5. So y times 2y gives me 2y squared. Y times negative 5 gives me negative 5y. Here, I'm going to take the 5 and distribute it to the 2y, and I'm going to take the 5 and distribute it to the negative 5. So 5 times 2y makes 10y, and 5 times negative 5 makes negative 25. So we've gotten rid of parentheses now. The next thing is just combine like terms. So here, the negative 2y and the positive y, those will make just a negative y minus 1 equals, over here, the negative 5y and the positive 10y, those add together to just make positive 5y. So there's where we're at. The next thing I'm going to do is I'm going to subtract 2y squared from both sides. 2y squared minus 2y squared, those will cancel out, and I'll have negative y minus 1 equals. Over here, 2y squared minus 2y squared, those will cancel out, and so I will have 5y minus 25. Then I want to get all my variables on one side, so I will subtract this 5y across. Negative y minus 5y gives me negative 6y. Minus 1 equals negative 25. Then I will add 1 on each side. And so I get negative 6y equals negative 25 plus 1 is negative 24. And then I'll just continue my work right over here. So I have negative 6y equals negative 24. So I'll divide both sides by negative 6. And so I get y equals positive 4. Now again, I want to check this before I box it in, so I want to plug it in. And again, I'm going to kind of cheat a little bit with my calculator. So I'm going to have parentheses 2 times 4 plus 1, close parentheses, open parentheses, 4 minus 1. So I get 27 on the left side. On the right side, I have parentheses 4 plus 5, close parentheses, parentheses 2 times 4 minus 5. I also get 27. So since they both got 27, I know this side does equal this side, so that means my answer is correct. So we're okay there. All right. So the next thing we're going to deal with is linear equations that involve fractions. When you have a linear equation that involves a bunch of fractions, the easiest way to deal with them is to just multiply every term of the equation by the least common denominator. Now, the least common denominator is the smallest number that all of the denominators can multiply to get to. Smallest number that they can all get to. Now, when you do this, when you multiply every term by that least common denominator, what will happen is the fractions will go away and you'll just have whole numbers. Okay? That's really nice. Now, these types of equations that involve fractions have a special name. They are called rational equations. So just know that. Rational equations means equations that involve fractions. Now, there is one kind of stipulation, and it's right here and underlined. This is really important. When you do rational equations, you do need to check and make sure that your solution does not make the denominator of a fraction 0. If it makes the denominator of a fraction 0, then it is not a valid solution, so we can't use it. So do need to make sure we check and make sure that the denominator does not become 0. So let's look at an example of this. Example 4 here asks us to solve 1 over x equals 1 over 5 plus 3 over 2x. So the first thing I want to do is I want to establish what is the least common denominator, the LCD. Let's start by looking at the numbers. I got a 5 and I got a 2. What's the smallest number that 5 and 2 can both get to? The smallest number they can both get to is 10. Then we look at the variables. We have an x and an x, so we need to make sure that our least common denominator includes an x. So our least common denominator is going to be 10x. And so what I'm going to do is I'm going to rewrite the equation first. 1 over x equals 1 over 5 plus 3 over 2x. And I left a little bit of space for a reason, because what we're going to do is we're going to multiply each term by this least common denominator. Now, since I'm doing it to every term of the equation, to everything in the equation, I'm not actually changing the validity of the equation, and so it's okay. It's allowed. Now, what's nice here is when we do this, this x on the bottom cancels out this x right here, and so all we have to do is 1 times 10. Well, 1 times 10, that's just 10. On the next term, this 5 on the bottom can cancel out with the 10. How many times does 5 go into 10? 2 times. So I have 2x getting multiplied by 1. 2x times 1 is just 2x. Plus, okay, over here, the x can cancel with the x, and the 2 can cancel with the 10. How many times does 2 go into 10? It goes into 10 5 times. So what we have is 3 times 5. 3 times 5, that's 15. So we have 10 equals 2x plus 15. We'll subtract 15 from both sides. 10 minus 15, that gives me negative 5 equals 2x. Then I'll divide both sides by 2. And so I'll say x equals negative 5 halves. Or if you'd prefer an exact decimal, this is negative 2.5. Now before we box it in, we need to do 2 things. 1, I need to make sure that when I plug this in, it doesn't make the bottom of the fraction be 0. And 2, I need to make sure that it actually makes the fractions work, that it actually makes the equation true. So if I check to see if it makes it 0 first, if I take negative 5 halves and plug it in here, I'll just have negative 5 halves on the bottom. That's not 0, that's okay. If I plug negative 5 halves in here, 2 times negative 5 halves would give me just negative 5 on the bottom. But that's still not 0, so that's okay. So this solution is not going to make either of these become 0, so we're all right there. We do still want to check the validity of it, though. So I got my calculator over here. So on the left-hand side, I have 1 divided by negative 5 halves. Now, you might notice I put the negative 5 halves in parentheses. That's to make sure that that division happens first before it divides the 1. Okay. So when we do that, we get negative 0.4. All right, now I'm going to do this side. On this side, I'm going to do parentheses 1 divided by 5, or the 1/5. Then I'm going to have parentheses, well, plus, and then parentheses, 3 divided by, open parentheses, 2, parentheses, negative 5 halves, small parentheses on this one. Then I'm going to close the parentheses for the negative 5 halves, then close the parentheses for the times 2 here, and then close the parentheses on the bottom. It's kind of crazy. Lots of parentheses on that one. But we also get negative 0.4, so we can feel pretty confident with our answer. We're pretty good. Okay? All right, next one. This is a little bit harder. Not too bad. It says solve x over x minus 3 equals 3 over x minus 3 plus 9. Again, we have fractions, so we want to look for the least common denominator. And it just so happens we only really have 2 denominators here, and they have the same denominator, so our least common denominator is just going to be x minus 3. So I'm going to rewrite the equation. X over x minus 3, leave a little bit of space, equals 3 over x minus 3, leave a little bit of space, plus 9. So I'm going to multiply everything by my least common denominator, so timesing everything by x minus 3. On this first term, the x minus 3's cancel out, and so all I have left is just an x. On the second term, the x minus 3's cancel out, and all I have left is a 3. And on the last term, I actually just have to do this multiplication out. 9 times x is 9x. 9 times negative 3 is negative 27. If I combine like terms, 3 minus 27, that's negative 24 plus 9x. Then I'm going to get my x's together, so I'm going to subtract 9x from both sides. 1x minus 9x gives us negative 8x equals negative 24. Then I want to divide both sides by negative 8. X equals negative 24 divided by negative 8. It gives me 3. So my possible solution is 3. Now what I want to do is I want to check 2 things. I want to check, does it make the bottom of the fraction 0? And does it make the equation true? Okay. So if I take it and plug it in, oh no, 3 minus 3, that gives me 0 on the bottom. So this solution doesn't work. Since that was our only possibility, this equation has no solution. There is no number for x that we can plug in to make this equation be true. So this is an equation with no solution. Okay. Moving right along, example number 6. Oops, going too far. Example number 6 says, in the United States, we measure temperature in both degrees Fahrenheit and degrees Celsius, which are related by this formula, C equals 5/9 F minus 32. Excuse me. And it asks us, what are the Fahrenheit temperatures that correspond to the Celsius temperatures of 0, 10, 20, and 30 degrees Celsius? Now, there are 2 ways you can do this. One way would just be to take these numbers and plug them in for C and then solve for F. But what I prefer to do is I actually prefer to rewrite this equation as F equals rather than C equals, just to make it a little easier for us. So I have C equals 5/9 over F minus 32. So what I want to do first off is get rid of this 5/9. And to get rid of this 5/9, what I'm going to do is I am going to, actually going to erase so that I have a little bit more space. See, I apologize if this gets a little jumpy. Sometimes my tablet does not work the way it's supposed to. So to get rid of this 5/9, what I am going to do is I am going to multiply by 9/5, which is the reciprocal of this. Now, why would I do that? Well, when I multiply by the reciprocal, the 9's could cancel out and the 5's could cancel out. And so the whole fraction would go away. But the thing is, if I do that on this side, I also have to do it on this side. So I have to put times 9/5 on this side as well. So here on the left-hand side, c times 9/5, that's going to give me 9/5c equals, here the 5's cancel out and the 9's cancel out, so all I have left is f minus 32. And then I can solve for f by adding 32 on both sides. And I apologize, my board's going a little wonky right now. And so what we have is 9/5 c plus 32 equals f. And now that we have that equation, we can figure out the f values for these by just taking these numbers and plugging them in here. So when c sorry again, my little board's going crazy. So when c equals 0, so 0 degrees Celsius, we're just going to plug 0 in here. 9/5 times 0 is just 0, plus 32 gives us 32 degrees Fahrenheit. All right. When c equals 10, well, we can actually use our calculator. So I can say parentheses 9 divided by 5, close parentheses, times 10 plus 32, and I get 50 degrees Fahrenheit. And then when c equals 20, we just plug 20 into our equation that we wrote. So we have 9 divided by 5 times 20 plus 32. So we get 68 degrees Fahrenheit. And then the last one they asked us to do was 30 degrees Celsius, so when c is 30. So we have 9/5 times 30 plus 32, and we get 86 degrees Fahrenheit. And so those would be our answers here for this function. Okay? All right. Next thing we're going to look at is some applied problems. We'll be doing some more of these a little bit later, but this is just kind of a little introduction. Our general steps for doing applied problems. Step 1, read the problem really carefully. Sometimes you might even read it 2 or 3 times. Pay special attention to what the problem is asking you to find. Figure out what is it wanting you to locate. What is the thing you want to know? Step 2, assign a letter, a variable, to what you are looking for, and try to write any other unknown quantities in terms of this variable. Meaning, if there's 2 different things you don't know, make one of them your variable, and then the other one, write it as some function of the first one. 3, make a list of known facts that you have in your problem and translate those facts into mathematical expressions. Sometimes what I'll do is I'll write the thing in words first, and then I'll just change the words into math expressions. This is usually going to include an equation, which involves a variable, and we can call that equation a model. And then once you have your model, fourth step is solve the model for the variable and get an answer for the question. Once you get your answer, write it down. You might even need to write a complete sentence. You might even need to include units. Just be sure that you do if that's what it asks for. And then step 5, check your answer with the facts of the problem and see if it seems reasonable. One example I usually give of this is, like, if I give you a problem and I say, how much money do you need to invest to have $100 after 5 days, and you tell me I need to invest $1 million, something's wrong. Your answer is not reasonable. So check for reasonableness. Okay? So let's look at some application problems here. So example 7 says a total of $18,000 is invested, some in stocks and some in bonds. If the amount invested in bonds is half that invested in stocks, how much is invested in each category? Okay. So there's a couple of things here. Okay, we have a total of $18,000, and some is in stocks and some is in bonds. So what that means is if I have stocks plus bonds, when I add them up, in total there has to be $18,000. Okay. But there's something else they told us too. The amount invested in bonds is half that invested in stocks. So bonds is equal to 1/2 of stocks. So what that means is, here where it says bonds, and here where it says bonds, those are the same thing. So I could actually take this and plug it in there. So what I could say is that I have stocks plus 1/2 stocks equals 18,000. Now, it's at this point that we'd want to pick a variable. So I'm going to come over here and I'm just going to say, let's let X equal the money in, wow, sorry, my board went crazy again. The money in the stocks. So that means what I really have is X plus 1/2 X equals 18,000. Now, since there's a fraction in there, I'm going to get rid of it. I'll multiply everything by 2. So 2 times X, 2 times 1/2 X, 18,000 times 2. 2 times X, that gives me 2X. Here with the 1/2 and the 2, the 2's can cancel out. So I just have 1X, or X, equals, over here, 18,000 times 2. Gives me 36,000. If we combine these together, 2X plus X, that gives us 3X equals 36,000. Then we can divide both sides by 3 to find X. So in my calculator, I'm going to do 36,000 divided by 3, and so I get 12,000. Now what was X again? Look back up here. X is the money in the stocks. So we already know that in the stocks we have $12,000. But that's not the full answer to the question, because the question asks us how much is invested in each category. Well, there are 2 categories, stocks and bonds. All we've answered is stocks. So we need to figure out how much is in bonds. You can do it one of 2 ways. You can either plug stocks back in here, plug in the 12,000 here and solve for bonds, or you can plug it in here and solve for bonds. Like you could plug it in right here for this stocks and say 1/2 times 12,000. That would be what bonds is. And that's what I'm going to do really quick. So 1/2 times 12,000, we get 6,000. So our amount in bonds is 6,000. And once we have that, we want to check our answer for reasonableness. Does it sound reasonable? We have 12,000 in stocks and 6,000 in bonds. Yeah, because those two numbers add up to 18,000, which is our number here. And that means that bonds is half of stocks, because 6,000 is half of 12,000. So yeah, it totally sounds reasonable. It does make sense. So there is our answer. Okay. All right. Last problem for this set of notes. This one says that Shannon grossed $725 one week by working 52 hours. Her employer pays her time and a half for all hours worked in excess of 40 hours. With this information, can you determine Shannon's regular hourly wage? Okay. So a way to think of this is, I'm trying to see if my little board will actually cooperate because it's kind of going silly now. Yep, it just disconnected, so let's try and reconnect it, see if that helps. Okay. So one way to think of this is when you make money at a part-time job, what they do is they take your wage and they multiply it by your hours. So, if you make $5 per hour and you work for 6 hours, they take 5 times 6 and say, okay, you made $30. Okay. But there's a little bit of an extra stipulation in this problem because it says that her employer pays time and a half for all hours worked in excess of 40. So what that means is she's getting 1.5 or 1.5 of her wage times the hours that she's over. I'm sorry, the little board's acting up. The hours that are over 40. And so that in total, when we take her wage times her hours, plus 1.5 times her wage times her hours over 40, that's going to equal the money that she made. It's going to equal how much money she made. Now, we do need to pick a variable here for what we're trying to find. We are trying to find her wage, so we're going to pick a variable for her wage. So over here somewhere, I don't know what is going on there, but I'm going to say let X equal her wage. Okay. So let's kind of fill some of this in. We know wage is X. Okay, hours. She worked 52 hours. Now, she gets paid this wage for the first 40 hours. So we're going to have this times 40. Plus, over here we have 1.5. We have her wage again, which is X. And then we're going to multiply that by her hours over 40. Well, how much is 52 over 40? Or in excess of 40? Okay, how much more is it? It's 12 more. So we have 1.5 X times 12. Equals, over here we have the money she made. Well, it shows us how much she made. She made $725. And so now let's clean this up a little bit. X times 40, that gives us 40X plus 1.5X times 12. I'm going to go to my calculator and do 1.5 times 12. So I get 18. So this is 18X equals 725. Add these together, 40X plus 18X, that gives us 58X equals 725. And we'll divide both sides by 58. to solve for x. X equals, for our calculator, 725 divided by 58. We get 12.5, so that's 12.5. So when we write our answer, we would say, because x is our wage, we'd say her wage is, a dollar sign here, $12.50 per hour. Okay. And then we can box that in as our answer. Does that sound like a reasonable wage? Yeah, it does. I mean, she's got a decent wage, $12 per hour. Plug it in there for your x, and you can actually check it. You can actually check this out and say, okay, if we take her wage, $12.50, multiply it by the first 40 hours she worked, plus 1.5 times her wage, $12.50, times the extra hours she worked, which was 12, and hey, look, it does come out as $7.25, so it does make sense. Okay, so that is it for section 1.1. If you have any questions, feel free to shoot me an email.